Hey, welcome to week 8. We're going to be doing lesson 8.3. So hopefully you're doing this lesson first and then the 8.2 lesson second. Sorry, I labeled them a little weird this week. If you don't, no big deal. But let's get started. So what we're going to be looking at this week is the idea of how do we find the equation of a line, right? So right here it says finding the equation of a line. um, Finding the equation. I guess it doesn't say of a line, but everything we've been doing so far is about lines. So we automatically, our brain goes y equals blank, x plus blank, right? Right away, equation of a line. We know we need to use that. And we're going to give you 2 points. And you can see in this first example down here, there are 2 points given to you. And sometimes, it's good to do the problems graphically. Remember, graphically means visually, using a graph. And so sometimes it's really nice to be able to do problems graphically because it shows us like the true meaning behind what's really going on in the problem. When we do things algebraically, it's lazy, right? Mathematicians are lazy. They want to find the quickest, easiest way to do things, and algebra is usually the quickest, quote unquote, easiest way to do things. But graphing and seeing visually what's going on can be a really great way to really understand the question. So that's what we're going to do in this lesson, is we're really going to get to the root of the problem and really understand what's going on. So let's get started. Do a couple examples. All right, the first example says find the equation of a line. So we always start by setting ourselves up for success. Y equals blank, x plus blank. That goes through the points -8. Remember, that's x comma y, and I've been using green for x and yellow for y all semester long. So I recommend you also do that. The more we use patterns and colors, the better our brain is going to remember it. All right, so the first thing we need to do is put those 2 points onto the graph. Again, if you're struggling with putting points on a graph correctly, that's okay. That's a very, very common problem. People just haven't done it for a long time. They forget how it works. Feel free to, Google it, or just reach out to me and I can get you some resources if that's what you're struggling with. So the first point is -8, 10. So you always do the x first. So here's our -8. And then the y second. Here is our +10. And then where those 2 lines come together, where those 2 grids come together, is where our point lies. Even though there's 2 numbers, there's only 1 point. That's a very common mistake that I see students make, is that they put a point at -8 and at 10. Nope, the point is at both. All right, the next point we need to put on is -6, 5. So here's -6, here's 5. We're going to put that point there. Beautiful. Okay, so we could just take a second here and imagine what our line is going to look like. So starting here, our line is going to go down and to the right, and we can kind of see that our B value might be -8. However, we can't be too sure. We need to double, triple check and make sure that we know. So how are we going to do that? We're going to find the slope using a slope triangle and then use that pattern to count our way to the y-axis. So this is very, very similar to what we've been doing in our other problems. Shouldn't be anything super new. We're just using the same ideas in a slightly different way. So remember, you always want to go from one point to the other. There's my rise in yellow. There is my run in green. The strategy that we use to count them is to count the boxes. We don't want to count the lines because that can be kind of confusing. Remember, we'd never count the box on the corner. It's like you're walking from one house to another, so we don't want to count. Turning a corner does not count as a block, right? All right, so here we can see our slope, our m value, is going to be 4/2. And if we put a slope person on the left-hand side of the line, that slope person would be going downhill So we want to make sure that we make that negative. Now I can see this and say in my head, that's negative 2 if I reduced it. Maybe you're not there, which is fine. Go ahead and go over to your calculator and just with every single slope that you find, see what that slope would be if you tried to reduce it. Sometimes it won't reduce, sometimes it will, but we want to make sure we're reducing every slope that could possibly be reduced. Okay, so now we're just going to follow that same pattern. And last week, I shared with you guys a cool thing that a student taught me, which is you can copy and paste your slope triangle. Nope, that's not what I wanted to do. And you can just not have to rewrite it every time. The bad thing about this is that you do have to be really careful that you're getting it exactly right. And remember that line that we made was not an exact line. It was our best guess. And look how far off our estimated line was, right? We have down 4 over 2, down 4 over 2, down 4 over 2. And so you might have thought it was going to be at -8, but that line was inaccurate because we're human. However, it gave us a good idea of where our line was headed, and it gave us a good estimate. So it's important to estimate what you think your y-intercept might be because it'll lead you in the correct direction. So that's b equals -10. All right, and then don't forget, if you're putting this into Schoology, you would want to rewrite it as y equals -2x minus 10. Get those pinkies up. Let's do another example. All right, so find the equation of a line. That immediately gets me started. Y equals blank x plus blank. And then I'm going to highlight my x's in green and my y's in yellow just to get my brain in the right spot. Okay, let's do it. So 5, -2 is 5 on the x-axis, 2 on the y. So that point goes right there. I like to erase those marks that I make just to keep my graph nice and clean. All right, the next one is at 10 and then -6. So we're going to put that point right there. All right, and I can already see that my line, right, the y-intercept is going to be somewhere around here. But again, just like we saw in the last example, we don't want to make any guesses, although it's good for us to visualize what our answer might be. We want to make sure that we know exactly what our answer is going to be. So we're going to get our rise over run, which is our slope. And we're going to use our great strategies for counting so that we don't make any mistakes. And we can see that our rise is 4. Oops, our rise is 4 and our run is 5. And so we know slope is rise over run, so we're going to say our m is 4 over 5. And again, this is going downhill, right? Our line is going to end up being negative. So we're going to say -4 over 5. Now I can look at that and say that can't be reduced. However, if you're not there yet, I respect that. You can always put in your slope into your calculator. It'll give you a decimal sometimes. Make sure you click the button down by the equal sign, by the EE number, that will turn it into a fraction for you, and you can see that it's the same number that you started with, so therefore it cannot be reduced. And right here and now, we could take that and put it into our equation because we know m goes in front of the x. All right, so if you're not a big fan of the copy-paste method, you can just count to figure it out. So remember, the pattern continues, and we need to go backwards to get to the y-axis. So we're going to go back 5, and then we're going to go up 4. And there it is. We found the point on the y-axis. Now, a very common mistake that I see students make is that they think the y-intercept is going to be -2. That's where the slope triangle hits the y-axis, but the actual line is the diagonal between the two sides of the slope triangle. So make sure that you don't put the point at -2, but instead our b value is going to be +2. All right, and so then we just put that number right there, and we're done. If you needed to put this answer into Schoology, it would look basically the same. There's nothing to simplify, nothing to make bougie about this one. It's just going to stay as -4 / 5x plus 2. Okay, you guys, go ahead and try these first two on your own examples and then come back. We'll do a couple more examples. All right, see you in a second. Okay, welcome back. Hopefully you're feeling some success in those two problems. Now we're going to bump it up a little bit. These ones, they're a little tricky. And there's no one right way to approach these problems. I'm just going to give you one way of thinking about them. If you don't like it, you can do it another way. Yeah, like I said, there's so many different cool ways to use logic to get the answer to these. So remember, we're finding the equation of a line. So I'm going to write y = blank x plus blank, just to remind myself, y-intercept and the slope, those are the two things that I need to find. One thing I could do on here is I could just, use my tools and estimate. It looks like my y-intercept should be -3. That's a little bit off, so I'm not exactly sure. How can I be sure? Well, we're going to do our slope triangle. It's going to be a big slope triangle. That's okay. We can handle it. We have really great counting techniques that we've developed. We fill the boxes 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can also look at the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, write this down before I go into that statement I was about to say. You could look at the numbers on the y-axis and the x-axis and add them together, subtract, or whatever to figure it out as well instead of counting. So when I look at this, I know that my slope is my rise over my run, and this is a positive slope. We're going up to the right, so it would be 12/9. And what I'm going to do is I'm going to put that into my calculator. I'm going to reduce this, reduce my fraction. Again, totally fine to get a fraction. All you need to do is just press the fraction button. And I realize I might be covering up the fraction button. So I think I'm no longer covering it up. So you're going to press the convert fraction there. And it says 4/3 because 12 and 9 can both be divided by 3. 12 divided by 3 is 4. 9 divided by 3 is 3. All right, so we have 4/3. So what we're going to do is we're going to use 4/3 for our rise over run. So that means I'm going to go up 4. 1, 2, 3, 4. And I'm going to go over 3, and that shows me officially that b is equal to -3. Now, on a quiz or a test, if you did not show that you understood that that was the exact thing, you just estimated using a line, you wouldn't lose all of your points for that question, but I might take off a little bit of credit just because I want to make sure that you really understand the whole concept and that you're not just estimating all the time. Both are important factors to understand, but getting the correct answer, although not everything, is still really important. So here's how you would put your answer into Schoology. Last example from me. This one is a lot. So those are the 2 points that we put onto our graph, kind of tricky points to put onto a graph. So feel free to ask for help if that's where you're struggling. Now we have to make this huge slope triangle. And in the next lesson, we're going to learn how we can do this without having to get a slope triangle. We are going to learn how to do it by hand. Now, I could count 1, 2, 3, 4, right? Go through all of them. but I know that it's 10 here and 10 here. So that's a total of 20. That's where I was saying you can use what you can see on the graph instead of having to count all of them. And then I'm about to run out of time. Oh no. Okay. I'm going to pause it here and then, or end the video here. I'm going to continue this question for just a couple seconds in a second video. So I'll see you in that second video.